friends, how are you? In the today's video, we will understand what is a method of joints. So for this, let's take this truss. And if I find out the support reactions of this truss and solve it joint after joint, I took this joint into consideration like this and took what are the forces going through this joint. If there is a support, then consider support reactions. After solving this joint, consider second joint. And like this, solve all the joints to get member forces in all the elements. So this is called the method of joints.
Engineering Fundamentals Guidance by Somayya Sir, Pune, and I am Yugandhara Talele. Content of the videos are Introduction, Truss, its definition, what is statically determinate trusses, types of trusses, and do you know what are zero force member? What is a plain truss? Then we will solve problems based on the two methods. First is method of joints and the second is method of sections. Now we will solve the problems. The first method is method of joints. We will see some notes and solve problem. Method of joints. So the typical procedure to solve the problems is like this. First, you have to draw structure FBD. What is structure FBD? When you remove all the supports and show the reactions offered by those supports, it is called a structure FBD. Then apply equilibrium equations and find support reactions. Now, here, as we are applying equilibrium equations to the truss as a whole, we will require three equations of equilibrium. Summation fx is equal to 0, summation of fy is equal to 0, and summation of m is equal to 0. Then, we have to draw FBD of joints one by one. We have to take into account single joint and show all the forces acting at that joint. And in the problem, you will see that these forces are concurrent forces. So you will need only two equations of equilibrium. Summation of fx and summation of fy is equal to 0. And then we have to find the unknowns. And the important step is solve joint after joint till we get all the member forces. Some notes for the method of joints. Joint that is taken for analysis shall not have more than two unknowns. While drawing joint FBD, unknown member forces shall be assumed tensile, that is force arrow away from the joint. Now for the first point, why it shall not have more than two unknowns? Because we have only two equations of equilibrium. As it is concurrent force system, we have only summation of fx and summation of fy is equal to 0. So we need only two unknowns. If positive answer is there, then it is a tension member. And if negative answer, then the member is under compression. After solving a joint, forces obtained are to be shown in the main figure before taking next joint for analysis. This is the important step. Now we will see problem based on the method of joints. This is the example. In this example, you can see this is a truss, triangular truss with support A as a pin support and support B as a roller support. You can see all the joints are pin connected and there are only joint loads. A joint load of 5 kN is applied at joint D and an inclined load of 20 kN is applied at joint C. In the beams video of the linear load, we have seen how to simplify this inclined load. Watch that video before. So the distances are given. The height of the truss is 1.5 meter and the span of the truss is 4 meters. From that, A to B is 2 meter and B to C is 2 meter. So let's solve the problem. So the first step of solving the problem is structure FPD. I already explained in the procedure what is structure FPD. So we have to show the reactions offered by this support. So this is a pin support. So how many reactions are there? Correct. Two reactions are there. And for roller support, there will be one vertical reaction perpendicular to the roller. So this is the structure FPD. So this is the structure FBD. I have removed the supports and shown the reactions offered by support. So after drawing the structure FBD, we have to find out these reactions offered by supports. So there are three reactions, two at support A and one at support B. And we have three equations of equilibrium. So we can find out the reactions. So first we will apply moment equation at support A. So why I have chosen support A? You can see there are two number of unknowns at support A. If I apply equations of equilibrium of moment at support A, these two reactions will pass through the support A and will be zero, will produce zero moment. So these two unknowns will get eliminated in that equation and I can easily find out the remaining unknown. So let's apply summation of moment at support A. And yes, don't forget the sign convention. The sign convention is the force positive direction of x is positive and Fy in the positive y direction is positive and anticlockwise moment is positive. So the summation of moment at A is Vb into 2 meter and it is positive as it is anticlockwise moment. Now this 5 kilonewton force at joint D. It is producing a clockwise moment. So this 5 into the distance is 1.5 meter. So negative of 5 into 1.5. And now we have to resolve this inclined load into its component for calculation in equilibrium forces. So this force is making 30 degrees with vertical axis. So according to the trick, the vertical component will be cos component of this force, and horizontal component, that is the remaining component, will be the sine component. Remember this trick. So the moment of this vertical component of 20 kilonewton force is creating a clockwise moment. So it will be negative. So negative of 20 cos of 30 into the lever arm is 4 meter is equal to 0. From this equation, there is only one unknown, VB. So we get it as 38.4 kilonewton. Now we will apply second equilibrium equation. Summation of Fy is equal to 0 to this whole truss. So let's apply. Va, it will be positive as it is in positive y direction. Vb, and this component we have as it is in downward direction. So minus 20 cos of 30 degrees is equal to 0. And summation of fx is equal to 0. So HA plus this joint load at D 5 kilonewton minus the horizontal component of incline 20 kilonewton force is equal to 0. After solving the equations of equilibrium, we get support reactions like this. HA is equal to 5 kilonewton, VA is equal to 21.07 kilonewton, which is in the downward direction, and VB is equal to 38.4 kilonewton. At any time, you can check these reactions if they are right or not by applying equation of equilibrium, any equation of equilibrium, example summation of moment at C, and check if it is 0 or not. Now we will need this angle, that is slope of the truss. So it is theta or phi is equal to tan inverse of 1.5 by 2, which is 36.86 degrees. Now, as this is method of joints, we have to solve joint by joint. So, first we will choose joint A. At joint A, you can see that there are these two reactions and these two members are there. So we separated this joint and we drawn the FBD of joint A. So show the forces correctly with their directions. So horizontal force of 5 kilonewton is shown here. Downward force of 21.07 kilonewton is shown here. And for these members AB and member AD, the tensile force is assumed. So I have shown it in green color, FAB and FAD. So tensile forces, that means forces acting away from the joint. So can you see these are concurrent force system or not? Yes, this is called the concurrent force system. So we only have two equations of equilibrium. The third equation, that is summation of moment equation, we cannot apply, as the forces are all passing through a single point. The lever arm will be 0. So let's apply summation of Fy and summation of Fx. This inclined force concept will be required everywhere. So please learn this method. So for this force FAD, we have found out the angle 36.86 degrees, and as the trick, this FAD is making an angle with positive x axis. So this horizontal component will be cos component, and vertical component, that is the remaining component, will be sine component. And for determining the directions of these components, take this force in the quadrant, like the quadrant of axis x y axis. Take this force into the quadrant and assume the direction of components. So summation of Fy is FAD sine of 36.86 minus 21.07, and summation of Fx equation, this 5 kilonewton plus this FAB plus this cos component FAD cos of 36.86 is equal to 0. So after applying these, we get FAB is equal to 35.1 kilonewton and FAD is equal to minus of 33.1 kilonewton. Now, after solving the joint A, we got answers like this. FAD is equal to 35.1 kilonewton. So, as we have assumed it as a tensile force, so it is positive. So, let's show that in our final diagram. FAD with arrows. Arrows acting inwards towards each other, and the force of 35.1 in member AD. And now for member AB, we got negative of 33.1. So let's see the sign convention for truss members. It's negative. That means the member AB is in compression. So the arrows will be like this towards the joint, or the arrows away from each other. So for member AB, it is 33.1 compressive. After solving and representing forces for joint A, we will solve the next joint, that is joint B. So let's draw the FBD for joint B. What are the forces acting at the joint B? Mm, this compressive force from member AB as 33.1 acting towards the joint. So let's show it here. Then the support reaction offered by support B, VB, is 38.4 kilonewton. So let's show that here. Then we assume the force in member BC as tensile force. So it is acting away from the joint. So FBC. And there is one more member BD. So let's assume it as a tensile force. So FBD acting away from the joint. So these are all linear. So let's apply equations of equilibrium and find out the forces FBC and FBD, the member forces. After solving the equilibrium equations for joint B, we got FBD is equal to negative of 38.4 kilonewton and force in member BC as negative of 33.1 kilonewton. So we have to represent it in our final diagram. Let's check the sign convention for truss members. It is negative, so it is in compression. Arrows will be acting away from each other, that is towards the joint. So for member BC, I have shown the force as 33.1 with arrows, and also for member BD as 38.4 compressive. Now you can see in this final diagram only one member is remaining, that is member CD. So for finding force in that member, we can either solve joint C or joint D. So here we will solve joint C. So let's draw FBD for joint C. What are the forces? For member BC, the compressive force of 33.1. Let's show that here. Then FCD, we have assumed it as tensile in nature. So FCD. And this inclined joint load of 20 kilonewton. Let's show that here in the FBD. Now we have only one unknown, FCD. So let's apply summation of Fy and find out FCD. It is 28.8 kilonewton. So the answer we got as FCD is equal to 28.8 kilonewton. The important step is to show that in the diagram, our main FBD. So at member CD, it is tensile force of 28.8. See the sign convention. The arrow for tensile force, that is for positive force, is the arrows acting towards each other for the member, or The arrow is acting away from the joint. So this is the solution of the our truss problem. See the direction of support reactions with the sign convention if they are properly shown or not. Then check for member forces for the truss members. Are they according to sign convention or not? Tensile member force is positive and the direction of arrows is really important. So after looking at the diagram, we can say that top chord is in tension and wave member and bottom chord are in compression. If you want to verify if these member forces are correct or not, then take the remaining joint, joint D, and solve it for equilibrium equations and see if the joint D satisfies them or not. That is, summation Fy should be equal to 0 and summation of Fx should be equal to 0. In this way, you can verify the answers. Thank you so much to you all for being with me throughout this video. Happy learning! I'm grateful for your support. We will meet in the next video. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.